So students, we are into the last part of this particular chapter, that is properties of halogens. We have discussed with you electrophilic substitution reactions, some other reactions also like Dow's process, preparation of aniline and all these things you have seen. Now, next today we are going to see that is reduction reaction. So see here, chlorobenzene. When chlorobenzene reacts with nascent hydrogen, now how will you get nascent hydrogen? You will take nickel aluminium alloy when it reacts with NaOH. Here, when nickel aluminium alloy, you know aluminium here it is an amphoteric substance. So it will react with NaOH to form sodium aluminate or sodium metaluminate, and hydrogen gas will be released when nickel here acts as a catalyst. Okay, so nickel aluminium alloy when reacts with NaOH, it gives nascent hydrogen. Again I repeat, aluminium will react with NaOH because aluminium is amphoteric in nature. Alright, but nickel here acts as a catalyst. So what I am going to get it? I am going to get benzene plus HCl. We can say that benzene plus HCl in this way. So we can say this is a conversion. Convert chlorobenzene to benzene. We can say. Next we will see when chlorobenzene is reacting with that is nothing but sodium. Now last class I had said you when chlorobenzene reacts with magnesium, reacts with lithium. Chloro means any chlorobenzene or bromobenzene or iodobenzene, anything you can take it here. When aryl halide I am talking to you. When it reacts with lithium, what we have seen it is that we have seen that is benzene ring and the first question Li. So you are getting an organometallic compound. In alkyl halides also we have seen it. That is we are getting an organometallic compound. So here also the same thing. So when chlorobenzene is going to react with what you can say lithium or magnesium. Once more if you want to see, I can write it and I can show it to you once again. So that is ether or THF you can take. Ether or THF here acts as a what? Inert solvent. Inert solvent, what it does? It provides a medium to carry out the reaction. It does not participate in the reaction. It just provides a medium. Or it's ether or THF. THF is what? Tetrahydrofuran. It is a cyclic ether. We can say that. So what I am going to get it? I am going to get that is nothing but an organometallic compound. What is that? MgCl. See if I take here Br, what will I get? MgBr. If I take here I, what will I get? MgI. So you are going to get an organometallic compound. You are going to get it. Alright, now what I was saying is that suppose instead of magnesium, if I take Li here, lithium, what I am going to get it? So here you are going to get, listen carefully, that is if I take lithium here, lithium, alright, so what I am going to get it? Li, benzene ring, first question Li plus LiCl, okay, or LiBr, whatever the aryl halide you have taken it, whatever the aryl halides. I think it's clear? Okay, now next is, here we will see some named reaction also. We will be saying it. For example, first one I am writing it is your Fittig reaction. Fittig. Let me write here Fittig. That is your Fittig reaction. Fittig. So here chlorobenzene plus sodium plus another chlorobenzene if I take. In presence of same thing I can take here ether or THF. It acts as an inert solvent. It just provides a medium. So what I am going to get it is here is that I am going to get diphenyl. This is your diphenyl. See here, 2 benzene ring diphenyl plus here I will take 2 sodium, 2 Na reacts with 2 chlorine to form what? 2 NaCl. I don't have the space here. NaCl I am writing it here. So 2 NaCl you will be getting it. So this is what is this compound is diphenyl. Diphenyl, and this reaction is known as Fittig reaction. Similarly, we are having Wood's Fittig reaction. Wood's Fittig reaction. So you have seen the Wood's reaction, that is in class 12. In this chapter you have studied, in 11 also you have studied. Here what I said you, Wood's Fittig reaction. Same thing, chlorobenzene plus 2Na plus here any alkyl halide you will take, any alkyl halide, CS3Cl or C2H5Cl or C3H7Cl, anything, in presence of again ether. What I am going to get it? I am going to get a very important compound here, it is, that is toluene, alright, and 2NaCl, alright. So again it is conversion, chlorobenzene to toluene, we can say that. Suppose if I take here C2H5, so you will get what? Benzene ring C2H5, that is ethyl benzene. So whichever the alkyl group you are taking it here, correspondingly that particular compound you are going to get it with the benzene ring. Okay, so that is known as, this particular compound is known as aryl alkyl compound. We can say that. Okay, this is aryl group, this is an alkyl group. Fine. So what is this reaction called as? Wurtz-Fittig reaction. W-U-R-T-Z. Wurtz-Fittig reaction. Next is we are going to do, that is your Ullmann reaction. This is also called as Ullmann biaryl synthesis. Ullmann biaryl synthesis. So here I have to take here, that is iodobenzene, and here I will take copper. Again another iodobenzene I will be taking it, and this I will be heating it in a sealed tube, in a glass tube, in a sealed glass tube I will be heating it. So what I am going to get it is that same thing, diphenyl I am going to get it. This is diphenyl, as you can see, plus here I am going to get Cu2I2, I am going to get it. So this is known as Ullmann reaction. We do Ullmann reaction with iodobenzene only, not chloro or bromo benzene we take it here. Okay, so this is your Ullmann reaction. So next we will have after this, so we have seen it, that is nothing but this reaction we have seen, the reduction reaction we have seen it, then the reaction with different, what you can say, halides, we have seen this particular reaction. Okay, now next what we are going to see is that is a polyhalogen compounds. Polyhalogen compounds, we can say that. Now under polyhalogen compounds, what we are having? We are having methylene chloride, we are having chloroform, we are having carbon tetrachloride. Now how do you get it? Remember it, you have studied in class 11, that is halogenation of alkenes. CH4 plus Cl2, what do you get? CH3Cl plus HCl in presence of UV light. Then CH3Cl plus Cl2, what is that you will get? CH2Cl2. Correspondingly, you will be getting CHCl3 and CCl4 respectively, we can say that. So this is polyhalogen compounds, we can say that. Similarly, you can prepare chloroform from carbon tetrachloride also. How you can prepare? CCl4 when it is reduced, when it undergoes reduction. In any reducing agent you will be taking, any reducing agent. For example, I am taking here zinc and HCl. What I will get? Nascent hydrogen. What I am going to get it here? That is nothing but CHCl3 plus HCl. This is your chloroform. I am going to get it. In this way you can also prepare chloroform. Okay. So this is polyhalogen compounds, we can say that. Still we are having some more compounds, we are having it. Alright, that is freon and all those things. So that you can go through it in your book. That is freon we are having. Just a little bit you have to study. Freon means what? CFCs. Chlorofluorocarbon, we can say that. Okay, now details about it I will say you in the entrance class. Now one thing, entrance students, let me tell you, on Sunday you will be getting an AV upon this particular chapter. It's a very important AV, you will see, you will be getting it upon this chapter. So please see that particular AV, it's very important. And I have already said you that this chapter I am going to conclude it today. I am going to conclude it. But you do the question answers, entrance students especially I am saying, you do the question answers from the previous year's book. And other students, of course, you will do the question answers from the practice paper which I have sent you, and as well as from your book and NCERT. And today also I am going to send you some more important questions I am going to send you. So please do it, this particular chapter properly. Okay, now next is we will see the preparation of DDT. What is DDT? Dichloro diphenyl trichloroethane. Again I repeat, dichloro diphenyl trichloroethane, we can say. Then after that we are going to see the IUPAC name. Let me write the reactions. Let me write the product, then I will explain you how we got the IUPAC name. So, now, how will you get it? See, I am taking here chloral, CCl3CHO. This is known as chloral. Or you can say trichloroacetaldehyde. What is acetaldehyde? CH3CHO. So, 3-chlorine is there. So, trichloroacetaldehyde. Now, here I am going to take it. That is chlorobenzene. This is one chlorobenzene and this is another chlorobenzene. Now you might be wondering that in chlorobenzene hydrogen where it comes. See, in every carbon atom hydrogen is there. Only I have highlighted this hydrogen atom which is being present here. I have highlighted it. That's it what I have done it. Otherwise in every position CH is there. Okay. Now next, when it reacts with H2SO4 conc. You know H2SO4 conc is a what? Dehydrating agent. It helps in the removal of water. For that reason I have taken H2SO4 conc. because if I don't take this, reaction is not going to take place. So H2SO4 conc is very important. Now you might you'll understand it, the why I wrote the compound in this way, because here what I am going to do, see here what I am removing it, water, H2O, because what I said, H2SO4 conc is a dehydrating agent. It helps in the removal of water. So whatever is left, that is your DBT. So what is left? See here, CCl3, here it is CH, here one bond with this particular one aryl ring, another with another aryl ring, plus water. H2 is being released. This is your DDT. Now we will see the IUPAC name. So this is your first carbon, this is your second carbon. So in the second carbon you can see 2 aryl halides is there. Okay. Now here in the second carbon 2 bis. Now you know it that if in the same carbon atom, listen carefully, if in the same carbon atom similar group is attached, then it is known as what? Bis. 2 similar group is attached, it is known as bis. If 3, then tris. If 4 similar groups, tetrakis. In this way it will go on. Got it? So 2 similar groups. So what is this similar group is? Para chlorophenyl. How it is para? See, first, second, third, fourth. So it is para. So it is para chlorophenyl. So 2 bis. In second carbon atom we are having this 2 bis para chlorophenyl, and in the first carbon atom 3 chlorine atom is there. You can see Cl3. 1 1 1. What is that? Trichloro. 3 chlorine. Now how many carbon? 2. So it is it. And what is that? Single bond. So it is N. So hence IPC name is 2 bis para chlorophenyl 1 trichloroethane. This is your DDT. Now DDT is actually an insecticide. Previously it was used. Now it is no more used because it is not biodegradable. It is non-biodegradable. It is not soluble in water. It is insoluble in water. Initially it was used as an insecticide, but now it is being seen that it is very hazardous, especially to animals, human beings, and the mammals. Alright, so hence it is no more used, this particular insecticides. The next one we will do is your BHC, benzene hexachloride, or it is otherwise known as gamoxine, or otherwise known as lindane. We can say that. So what I am going to do, I am going to take benzene plus chlorine, alright, in presence of H nu or UV light. We can say that. What I am going to get? I am going to get, that is 6 chlorine atoms, alright, plus now 6 hydrogen is removed. Clear? So it is 6 chlorine atoms, 6 hydrogen I am saying, it is being added. So 6 chlorine atoms is being added there. So hence this is known as what? BHC. BHC, benzene hexachloride. See, benzene hexachloride. Or it is known as lindane, or it is known as gamoxine. You know, gamoxine is used for what? It is used to kill that is red ants or insects. We can say that. It is also an insecticide. So in this way, this is a preparation of BHC, that is gamoxine. Now, so this is all about the reactions. Now you will be getting the questions in this chapter. Very important question is that how to differentiate between aryl halides and alkyl halides. For example, if I am giving you chlorobenzene and chlorohexane, let us see how to differentiate it. Now here you see chlorobenzene. This is your chlorobenzene, we can say. Clear? Chlorobenzene. Clear? And chlorohexane, 6 carbon atoms will be there. 1 2 3 4 5 6 and Cl. Of course we will put the hydrogen, CH2 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 Cl. Fine. So here what you find is that this chlorine atom, listen carefully, this chlorine atom which is attached to the alkyl group or to the benzyl group, alright, or to the allyl group. Now what is benzyl? Benzyl means this is your benzyl. Benzene ring CH2 group is known as what? Benzyl. Now let me rub it this one. Benzene ring CH2 is known as what? Benzyl. So what I said, benzyl group. Other one what I said, allyl group. Allyl means this is your allyl. CH double bond CH2. This is your allyl. So it is alkyl, benzyl and allyl. So when the halogen atom is attached to either to the alkyl group or to the benzyl group or to the allyl group, the halogen atom is known as labile in nature. Labile means which is reactive. But when the halogen atom is attached to an aryl group or attached to a vinyl group, CH2 double bond CH, this is your vinyl. vinyl group, that is said to be it is said to be as inert in nature. Inert, it is said to be as. When the halogen atom is attached to the, that is aryl group or to the vinyl group, vinyl, that is known as inert in nature. Inert means it is not going to react. It is not going to be replaced. So, what I am going to do? I am going to, what is, differentiate this. So, how to differentiate? I will take chlorobenzene and I will take these two compounds. In both the compounds, first I will add, that is NaOH or KOH, aqueous or alcoholic. So what is going to turn? Now this is going to react with NaOH or KOH, aqueous or alcoholic, to form alcohol. Like here, hexyl chloride or chlorohexane, it is going to form hexanol. But this is not going to react with it. What I said you? The chlorine atom attached to it is inert in nature. Here the chlorine atom attached to it is labile in nature. This and this. Here we can say that labile, which is reactive. So it is going to form what? Hexanol. Now what you do is that you add that is dilute HNO3 to acidify it. Got it? And then add silver nitrate solution to it. What I said? After forming hexanol, you add dilute HNO3 to acidify it and add silver nitrate solution. You will get a white PPT here. But here no such reactions. In this way we can differentiate between chlorobenzene and chlorohexane. We can say that. Now if suppose bromo is there, here bromo and here bromo. So same you will do it, same thing you will do. You will add first NaOH or KOH, aqueous or alcoholic, then add dilute HNO3, then silver nitrate. You will be getting pale yellow PPT. Got it? With this in alkyl, not with this. No reactions with this. With this or this. You will be getting pale yellow PPT. But with vinyl and aryl, no such reaction is going to take place. So this differentiates between chlorobenzene, chlorohexane, or it may come in your exam, benzyl chloride, chlorobenzene in this way, or allyl chloride, vinyl chloride in this way. Different type of questions you will be getting it. So just one answer, remember it, I said you for all. So this is a test to differentiate between the compounds. Thank you very much.